discuss trigonometry theory and inverse trigonometry theory first, then we'll discuss questions over these. So first let me start with basic trigonometric identities. Okay, you know sin square theta plus cos square theta equals to 1, sec square theta minus tan square theta equals to 1, and similarly cosec square theta minus cot square theta equals to 1. So here you have to know these domains. This is the domain, this is the range of sin theta which lies between 1 to minus 1, and theta can be anything. Similarly cos theta can be 1 to minus 1 and theta can be anything, belongs to R, real numbers. Then similarly mod sec theta has to be greater than 1, okay, which means sec theta has to be greater than equal to 1 and less than equal to minus 1, correct? And theta belongs to R. Similarly for cosec theta. Now here are some another ratios which we need to know, like you know value of sin pi by 3, sin pi by 6, but you also need to know the value of sin pi by 12. And okay, how can you derive it? Okay, you can derive it, but you need to learn all the values. Like sin 15 can be derived with the help of formula cos 15 degree, which is equals to sin 30 degree divided by 2. Okay, sin 30 degree I know its value. Cos 15 degree can be written as under root of 1 minus sin 15 degree ka square. Okay, when you solve this equation, you'll get the value of sin 15 degree as root 3 minus 1 upon 2 root 2. But while giving exam, you don't have to like derive this thing. You need to learn all the values of it. Okay, similarly all the values tan 15 degree, cos pi, sin pi by 8, sin pi by 10. These are important values which you need to learn. Okay, here's this thing. Okay, this is in quadrant 1, you know sine, cosec, tan, cot, cos, sec, everything is positive. Like sine of theta is positive. Theta, if it's between 0 to 90 degree, it's going to be positive. Now 90 to 180 degree, if you see, sine and cosec are the positive thing. I'll explain you this. Like sine of minus theta is minus sine theta. Why? Because it lies between 0 and minus 270. This is 360, right? Sine of 90 minus theta is cos theta, but sine of 90 plus theta is also cos theta. But if you see, cos of 90 minus theta is sin theta, but cos of 90 plus theta is minus sin theta. But because cos of 90 plus theta lies in second quadrant, which is negative for cos theta, so here minus sin theta will come. So you have to take care of the positive and negative signs. Okay, here are a few of the trigonometric equations. Like sin of a plus b is equals to sin a cos b plus cos a sin b. Lekin sin of a minus b is sin of a cos b minus cos a sin b. Similarly cos of a plus b is cos a cos b minus sin a sin b, and cos of a minus b is cos a cos b plus sin a sin b. Similarly, okay, for this thing sin square a minus sin square b equals to sin of a plus b plus sin of a minus b. ये कैसे आया? अभी I'll derive it. Like sin of a plus b can be written as sin a cos b plus cos a sin b into, I'll write the formula of sin of a minus b, sin a cos b minus cos a sin b. When you multiply this, let's say this is a, this is b, this is again a, this is b. So it comes a plus b into a minus b, which is a square minus b square. So I can write this thing as sin square a into cos square a minus sin square b. Okay, this is sin square a, this is cos square b, and sin square b into cos square a. Okay, I can write this thing as 1 minus sin square b, and this thing as 1 minus sin square a. Okay, when you multiply each of these terms and subtract it, you will get sin square a minus sin square b. Because ये जो माइनस माइनस करेंगे तो यहाँ पर आएगा माइनस साइन स्क्वायर ए साइन स्क्वायर बी, और यहाँ जो मल्टीप्लाई करेंगे माइनस माइनस मल्टीप्लाई करेंगे तो आएगा प्लस साइन स्क्वायर ए साइन स्क्वायर बी, जो कैंसिल हो जाएगा. सो ये फॉर्मूला ऐसे डिराइव हो जाएगा. सो देयर आर अदर फॉर्मूलाज हियर. sin c plus sin d is 2 sin c plus d into cos c minus d by 2. Sin c minus sin d is 2 cos c plus d by 2 into sin c minus d by 2. Cos c plus cos d is 2 cos c plus d by 2 cos c minus d by 2. Okay, while you refer this equation, you have to keep this thing in mind. Cos c minus cos d is 2 sine c plus d by 2 into sine d minus c by 2. See, this minus sign I've written like this, d minus c by 2. Anyway, you can learn this formula, but keep this thing in mind. Okay, here's another set of formulas like 2 sine a cos b equals to sine of a plus b plus sine of a minus b. What you can do here, you can expand these sine of a plus b into sine a as sine a cos b plus cos a sine b, and this thing as sine of a minus b, sine a cos b minus cos a sine b. When you add these both, you'll get 2 sine a cos b. When you do questions, you'll know how to use this formula. We'll do questions later. These are set of formulas which are really very important. Okay, very important up till here. Okay, sine 3a is 3 sine a minus 4 sine cube a, and cos 3a is 4 cos cube a minus 3 cos a. You can you don't need to learn actually formula of tan 3. You can write it simply as sine 3a upon cos 3a. But in this case, when you see this question tan 2a or sine 2a, you need to learn these formulas. You can't skip tan 2a. Can be written as sine 2a or cos 2a. These are really important formulas when it comes to solving questions. Now this is triangle properties which you need to know. When angle a plus b plus c is equals to pi, this is expansion of tan of a plus b plus c. Just tan a plus tan b plus tan c, which can be also written as summation tan a minus product of tan a upon 1 minus summation of tan a tan b. This thing can also be written as this, in this way. When a plus b plus c equals to pi, okay, when a plus b equals to c is equals to pi, let me write this as tan of a plus b as sin theta upon cos theta, where theta is equals to a plus b plus c. Correct? When this thing is equals to pi, I know this thing sin theta sin of pi is equals to 0 when theta is equals to pi. When sin pi is equals to 0, I'll say summation of tan a is equals to product of tan a. Correct? So here's the property which is written, summation of tan a is equals to product of tan a. Correct? When a plus b plus c equals to pi by 2, theta is equals to pi by 2, I know cos of pi by 2 is equals to 0. When this thing is 0, I'll write summation of tan a tan b as 1. Okay. And there are another two properties on this thing, a plus b plus c equals to pi, which is sin 2a plus sin 2b plus sin 2 is equals to 4 sin a sin b sin c, and sin a plus sin b plus sin c equals to 4 cos a by 2 cos b by 2 cos c by 2. These another two properties are really important when it comes to triangle questions. Okay, now JEE questions usually come on this thing, maximum and minimum values of an expression. So you need to know this thing, that minimum value of this expression is 2ab, maximum and minimum value of this expression is this for any value of theta, for a particular value of theta. Similarly, these are all the properties which you need to know. Okay, here I start the theory of inverse trigonometry. Let me start with y equal to sin inverse x. Let me show you how x lies between 1 से minus 1. I can write this thing as x equals to sin y, and I know sin theta always lies between minus 1 से 1. So I can say x also lies between minus 1 से 1. So, and y is between pi by 2 से minus pi by 2 because of the quadrant thing. The inverse functions, first quadrant is common to inverse function and third quadrant is not included. And for some functions, its fourth quadrant is also included. Similarly, for other functions, domain and range are defined. These are the properties. When you see this property, sin of sin inverse x equals to x, you have to keep this thing in mind that x lies between 1 and minus 1. Similarly, for tan of tan inverse x, x belongs to r. For cos of cos inverse x, again equal to x, x belongs to 0 से pi. So these things have to be kept in mind when you refer to these properties. Again, there are some properties which you need to learn, that cosec inverse x equals to sin inverse of 1 by x. You know that, like, you have learned this thing is equals to 1 by cosec x. So similarly, it's defined for sin inverse functions also. Sin inverse of minus x is equals to minus sin inverse x for x 1 से minus 1. Like cos inverse of minus x is pi minus cos inverse x, not minus of cos inverse x. This is for cos and cot. You have to keep this thing in mind. another property, that sin inverse x plus cos inverse x equals to pi by 2, tan inverse x plus cot inverse x is pi by 2, and cosec inverse x plus sec inverse x is pi by 2. Okay, let us see the property 5 of inverse trigonometry, which is tan inverse x plus tan inverse y is equals to tan inverse x plus y upon 1 minus xy. But here's another thing which is written, it is also equals to pi plus tan inverse of x plus y upon 1 minus xy. Okay, what is the difference? You see, x is greater than 0, y is greater than 0, but x into y is less than 1. Here x is greater than 0, y is greater than 0, but x into y is greater than 1. So according to the domain, you have to remember all these formulas. When you apply this thing, if x and y product multiplication is greater than 1, you have to apply this formula, otherwise this one. Now the property 6 says sin inverse x plus sin inverse y is equals to sin inverse x under root 1 minus y square plus y under root 1 minus x square. Okay, how this property, I have shown this derivation in one of the questions, so you can see there another set of properties which is also based on the domain. According to the domain, you have to use different formulas. Keep this thing in mind. On the property 7, tan inverse x plus tan inverse y plus tan inverse z equals to this. If this is a domain thing, but keep this thing in mind. If x plus y plus z minus x y z if this thing happens, then tan inverse x plus tan inverse y plus tan inverse z equals to pi. Similarly, if xy plus yz plus zx equals to 1, then tan inverse x plus tan inverse y plus tan inverse z equals to pi by 2. Okay, how can this thing be derived? See, x plus y plus z minus xyz. Okay, this is equal to, when this thing is this, which means this is tan inverse of 0 comma something, right? So I can say that this thing can only happen when this summation is pi, or iska xy plus yz plus zx equals to 1 can only happen when this summation is pi by 2. Now the property 8 of it. Okay, this is the basic formula, and it has been distinguished according to the domains. Okay, so here I'll show you how y equal to sin inverse x y equals to sin inverse x graph came. Okay, if you see this graph y equal to sin x, okay, when we take its reflection in this equation y equal to x, we get the graph of sin inverse x. Okay, when we take a reflection of a graph from y equal to x equation, the coordinates changes, it transforms into y comma x. So if you see this point, this is what, minus pi by 2 and minus 1, and I know that y equal to sin inverse x. Okay, when I put this minus pi by 2 here, I get y equals to 1. So minus pi by 2 comma 1. Here's the reflection taken of this point. If you take reflection of every point, you will get the graph of y equals to sin inverse x, which is shown here. Okay, if I take the reflection of pi by 2 comma 1, I get this point 1 comma pi by 2. So here's the if we see the graph of y equals to cos inverse x, and I draw the graph of y equals to cos x, and I take this reflection in y equals to x, I get the graph of y equals to cos inverse x. Similarly for tan inverse x, cot inverse x, sec inverse x, and cosec inverse x. Here I'll explain you the graph of sin inverse of sin x. Okay, this function is periodic with period 2 pi. So I know y equals to sin inverse of sin x, where x lies between pi by 2 say minus pi by 2 is equals to x, correct? I also know that sin inverse, I can write this sin x as sin of pi minus x. Okay, this can be written as pi minus x when x lies between 3 pi by 2 say pi by 2, correct? I just replace this thing into this domain. Okay, so when I see this, when x lies between pi by 2 say minus pi by 2, y is equals to x. So I have drawn this thing, y is equals to x when x between minus pi by 2 say pi by 2. When I replace this thing, I get pi minus x, y is equals to pi minus x, which where x lies between pi by 2 say 3 pi by 2. Okay, so here I draw this again. Now I see this function is periodic with period 2 pi. So I continue drawing this graph. With a period of 2 pi. Okay, this is one way to derive this graph through this equation. What you can do is you can remember this graph and derive these equations from this graph. Okay. Similarly, you can derive the graph of cos inverse of cos x, tan inverse of tan x. Let me let's see this graph. Y equals to sine inverse x, which is equal to x, where x belongs to -171 and y also belongs to -171. How? Okay, I know that here sine inverse x domain always lie between let me say that E is equals to sine inverse x. Again, x equals to sine. So sine E lies between -171. So I can say x lies between -171. And since this is y is what? Sine of theta, where theta can be anything. Right? The y also lies between -171. So here I can draw this graph. But if you see, this thing does not extend from -171. It remains here. It does not extend. Okay. Similarly, y of cos inverse x. So, let me see this. Y of tan inverse x. X belongs to R, y belongs to R. It is extended. In this thing, again, what I did here. This is sine inverse of sine pi minus x. You have to do the same for tan of tan inverse x and etc. Now, this thing. Y equals to sec inverse of sec x. One thing has to be kept in mind. At pi by 2, sec inverse of sec x is not defined. Okay, so you have to keep this in mind. These points are not included. Similarly, in sec of sec inverse, here this portion is not included because sec of sec inverse x is not defined at this point.